All right, for this section, the greatest part about this is that there is nothing new to learn. This section is just about applied optimization, which just means it's the same thing as what we did in the last section, except now we're going to have word problems. So really, there's nothing new in calculus to learn. Technically speaking, I should not have to teach you this section. But what I will say is there are a few formulas related to business that you're going to need to know. They're nothing magical. There's nothing special. It's just kind of the idea of profit. Whenever you hear the word profit, we need to have some relationships in our head. We need to understand what that's coming from. And one of the most common formulas we end up using is the idea of profit is it's equal to revenue minus cost. Okay, so that's one key formula you're going to end up needing. Another one is the concept of revenue. Okay, so what is revenue equal to? Where does revenue come from? And revenue is just the concept. It's a very simple concept of how much money did we make? How do we bring that in? And it's a simple idea, just saying, well, it's the price that you're selling something at times how many of them you sold. Number sold. Price times the number. There we go. So those are two super important formulas for this section. There's probably some more, but those are the two that come up a lot. So if you run into a scenario, what I always want you to do is stop and think about what information are they giving me, how do I relate it to get my answer. Okay, so here we go. First problem. Notice this problem is giving us a cost and a price, and what they're asking us to do is to maximize the profit. So whenever we're trying to do one of these problems, we stop and think about, all right, let's see. In the last section, when we are maximizing, like what we would do is say, okay, we've got y equals x squared plus 2 or whatever it was. And if we're maximizing, and that meant we're taking the derivative of y, right? Well, and that would be maximizing our function. Well, in this case now, if we want to maximize profit, well, we'll say we need a profit function, and then once we get our profit function, we're going to do the derivative of that. So let's write a profit function. How do you make profit? Well, profit is revenue minus cost. Do we have anything like that? Well, let's see. Given the cost function and the price function, find the product level that will maximize profit. And we're going to assume that x is the number of items being created, number of items being made, because they're asking us to find the production level. So let's call x the production level. Okay, so what we're going to do is say, all right, I've got to use this information. How do I do it? Well, we know profit is equal to revenue minus cost. We don't have that here. So what we're going to need to do is we have a profit. We want the profit, and we have cost, which is one thing we're going to need. But we have the price. So how do I take that and turn it into revenue? Well, the price, what we see up above from right here, we know, whoops, the blue highlighter will not be too helpful. We know the price is equal, the price times the number, there we go. So 1710. All right, so there's a price. Now, how do I represent the number of items we're selling? Well, that's just x, right? That's the production level. So however many of them we make, take that, multiply it by x. Okay, and that is this piece right here. This together makes our revenue. So therefore, now we have our revenue, and what we need to do is subtract that from our cost. And our cost, we already said, is that this equation right up here is this one. So we're just going to go ahead and fill that in. All right, and now, how do we do this problem? Well, if you see it, then this problem really has now just become a section 2.7 problem. All we're going to be doing is taking the derivative of this. So p prime, or I would prefer dp dx. I'm a much bigger fan of this notation for word problems because it helps you read your answer at the end a little easier. Now, actually, I should say though, are we ready to take our derivative, or might we want to do a little algebraic simplification first? I'd say the algebraic simplification may help, um, just because what we can do is combine our like terms and distribute this negative sign, make sure we don't make any silly little mistakes, just from not showing our work in between. Oops, there we go. Okay, so now we have 1710x minus 50710x. So that's going to be what? Let's see, negative 8,800 plus. Um, I'm too tired to do this in my head. I'm using the calculator. Don't tell anybody. Shh. All right. So let's see here. 1,710 minus 570. 1,140. Perfect. Okay, so that's 1,140x minus 1.5x squared. All right, so now we are at the point where we could say, all right, this is as cleaned up as we're going to get it. Now it seems like a good time to take our derivative. All right, so here we go. So we take our derivative, that's a constant, so it's 0. So this is going to be 1,140 minus, bring this 2 to the front, 2 times 1.5 is 3x. Now, how do you find maxes and mins? Well, we have to remember that from the last section, what we talked about was anytime you have a max or a min, you know the derivative is equal to 0. So we're going to now take this function, set it equal to 0. Beautiful, and we solve it. So we subtract the 1,140 over to the other side. So divide by 3, so this is going to be x equals 1,140 divided by 3, because the negative, it's a negative and a negative. And I don't know about you guys, but I'm using my calculator again. It's 380. So therefore x equals 380. So therefore, what does that mean? What does that mean? The production level that maximizes this situation would be 380 units will, I should write the word units, 380 units will maximize production, or profit. Now, the next question is that what the question asked us for? Did it actually ask for the profit, or did it just ask for the production level? And you'll notice in this problem, it asked for just the production level. So we're done. We don't need to do anything else. Now, but what if the problem did ask us for what profit would we make at this production level? Well, if it asked you for the profit as well, or if we needed to know, then what we'd have to do is take our 380 and sub it back in for all the x's. And then that would give us the profit. And you could either do it there, or you could do it on the simplified line, whatever you like. Okay, I hope that made sense. Now, the next type of problem is one that I love to give you guys because it is a bit challenging, and it makes you think, but when you stop and kind of think about it, you realize it's not too bad. And it's really a challenging problem, especially because what they're asking you to find is not necessarily what you'd naturally be wanting to find. So it makes you have to just think differently than how you might normally want to. So it's asking us to find a price function. Okay, so output price and the input is where X is the number of television sets sold per week. So we need the input to be the number of television sets sold. So now, when we read through the problem, it says the manufacturer has been selling 1,300 television sets a week at $360 each. So the price for our function, the price here may not be an X. We'll see. But right now, it sounds like they're selling them at 360 a week. Is it always 360 a week? Well, a market survey indicates that for each $24 rebate offered to a buyer, the number of sets sold will increase by 240 per week. So what we're talking about is changing the price. What we're talking about is offering a $24 rebate. And it doesn't have to be just one because it says for each $24 rebate. So what we're going to do here is we're going to say, all right, the price is $360 right now, but a rebate would bring that price down. So what we're going to do is say the price of $360 minus $24 rebates. But how many rebates are there? I don't know. So what we're going to do is multiply that by R. So if there's one rebate, it's minus $24. If there's two rebates, it's minus $48, etc., etc. Okay, so there's our price function. Yay! Except there's one little problem here. There's one little problem. It looks like P raised to the rice. All right, here we go. Price. There's one little problem. We want it in terms of X. We don't want it in terms of R. So let's see what we can figure out. Well, this is where substitution method really comes in handy. What we're going to say is, well, what is R? R is the number of rebates. So if we can come up with another equation that has something to do with rebates and X, then we can substitute in, and you'll see in just a second if that's not jumping out at you. So let's keep reading here and say, all right, we definitely need another equation. All right, the next one says, or the next part of this says that the number of television sets, this was the price, which was 360, but now we're also looking at the number of sets. The number of television sets here was 1,300 TVs. So, what variable do we have to talk about the number of sets? Well, that's X. So X is equal to 1,300 TVs, but again, that's not staying still, that's changing because for each rebate we offer, the number of sets you sell increased by 240. So therefore, this is plus 240 TVs times the number of rebates we sell. And now you'll see that both these equations have R in it. We don't really care about R. We just want price in terms of X. So what we can do here is solve for R, solve this equation for R, and then sub it in. So let's see here. What would that be? X minus 1,300 equals 240R. So therefore R equals X minus 1,300 divided by 240. So now, everywhere I have an R, I can replace it with this equation here. So therefore we know the price is equal to 360 minus 24 times X minus 1,300 divided by 240. So now if you look at this, what we actually have is P of X, don't we? Because we have a function here that is describing the price. The output is price, and the input is X, and X is defined as the number of television sets sold per week. So we have done it. Yay! Okay. So that's part of the challenge to this homework assignment, is just getting creative and saying, what do they have? What are they asking me for? And how do I build it? So now the next part says, how large of a rebate should the company offer in order to maximize revenue? Now listen to what the question's asking for. Maximize revenue. If we did the derivative of this function up above, this isn't revenue, this is price. So therefore, that would not get us what we need. That would actually it'd be answering the wrong question. So what we have to go back and say to ourselves is, how do you find revenue? What is the formula for revenue? Okay, so let's see. Revenue is the concept of how much money you're bringing in. And that formula, which I remind you at the very beginning, is this one right here. It's just the price you're selling it for times the number of items you're selling. Well, so if you stop and think, this one should jump out at you. We just created an equation for price, right? It's price times the number sold, right? Okay, so therefore revenue is equal to the price equation, 360 minus 24 times X minus 1,300 divided by 240 times, and careful with your parentheses, make sure you really break this down. That's the price equation, okay, and then times the number of items sold. Well, how do you figure out the number of items sold? Well, that's just the definition of X, right? So therefore, boom, there we go, we've got it. And of course we can simplify a little bit in this previous equation if you wanted to, because notice we have 240 dividing 24, so this would just be, what, divided by 10? So therefore that would clean this up just a tiny bit, make it a little easier. Alright, so now when we're dealing with this, we want to maximize revenue. So whenever you hear the word maximize, now that we know calculus, that means take the derivative, right? dr dx. Okay, now, are we ready? Do we want to take the derivative now, or would it be nice to do a little algebraic simplification? Because right now what I'm seeing is a function of x multiplying a function of x. So we would have to do product rule, where instead if we just distributed this through a little bit, it might help us out, might make it a little easier. So I'm going to do a little distribution. So let's see, revenue is equal to 360x minus x times x minus 1,300 divided by 10. And we could now distribute this x through, right? So therefore now we're going to have revenue is equal to 360x minus x squared divided by 10 plus, let's see, 1,300 divided by 10 would be 130, so this would be 130x. Oh, and look at that. We have like terms now. So therefore now we can even do revenue is equal to, let's add those. So that's 490x minus x squared divided by 10. Now this looks pretty clean. Looks as good as we're going to get it. So let's go ahead and now, I didn't want that all in blue. Let's go ahead and, there we go. That'll be green. There we go, our derivative. All right, so dr dx, the change in revenue with respect to change in revenue per change in number of units sold. So when I do that derivative, that's going to be 490 minus, bring the 2 out to the front, so that'd be x divided by 5. Okay, now what do when we're trying to find max? Well, we know that revenue needs to be equal to 0, so I'm going to cheat, and just because I'm out of space here, I'm going to cheat and put that equal to 0. Okay, now let's solve. Subtract the 490, multiply by a negative 5, so therefore that's going to give me x equals 490 times 5. And it is early here, so I am cheating once again and using my calculator. 2,450. All right, so therefore 2,450. So what does that x mean? Don't forget to interpret. The variable x was defined as, again, the number of television sets sold, right? So therefore, we have just found we will maximize our revenue when we sell, max revenue, when you sell 2,450 television sets. So, is that the question they asked us? Unfortunately not, because notice when you go back and read, this is a key to word problems. What did they ask us? How large of a rebate should we offer? Well, it's not. So unfortunately, this was not needed, but we can use this x equals 2,450 to go back and figure out, because in the last problem we had a equation, right, that dealt with rebates. R was the number of rebates that we were the number of rebates we were going to use, right? And so therefore, if we just take this equation that dealt with our rebates right here, right, and we go ahead and I'll write that back down here. We know rebates is equal to x minus 1,300 divided by 240. So, and if we pop that in, if we substitute in, we now know what x should be. So let's go ahead and do that. So let's sub that in. So that's going to be what? 2,450 minus 1,300. And then take the answer of that, divide by 240. And that's going to give us R is equal to 4.7916, repeating. I hope I didn't make a typo there. That seems okay. All right, so what does that mean? What does that mean? Is that a nice fraction? Not really. That's still just the number of rebates. That's not the actual answer. That's just our number of rebates. So therefore, nope, that's right. Okay. I'm just looking for a mistake. Let me pause and see if we made a mistake in our math anywhere. No, nothing's really jumping out at me except the one little nice thing here is what when I write this as a fraction instead, you'll see it's 115 divided by 24. Okay. So remember, what this means is the number of rebates that we should be offering, not the actual amount of the rebate. So what this is saying to me is it's 4.79166666 rebates. Well, remember how the problem was defined in the very beginning. When we talked about the rebates, it was for each $24 rebate. So if we want to figure out the actual amount that we should be, the amount of the rebate, what it should be, if this is the number of rebates, then what we should be doing is taking this to find the amount, is say just do this times the $24 rebate, and you'll notice it works out. So what this is telling us is the rebate should be $115. If we offer a $115 rebate, then we will maximize our revenue, which we found earlier. Um, we'll maximize our revenue. Um, and there you go. So now if you wanted to, you could take this x and substitute it back into the revenue equation to figure out what that revenue would be. But you may not care. You might just say this is the best we can do is when we offer a $115 rebate. Okay, and for this next part here, it's saying cost. Now we have cost. So this should hopefully seem familiar. How should the company set the size of the rebate to maximize profit? So if your goal isn't to maximize revenue, if your goal is to maximize profit, then it's a slightly different question. Now, the nice thing, we already have a function of revenue, right, in terms of x, and here's a cost function in terms of x. So if I were to create a profit function, right, profit, we know profit, excuse me, let's use a P. We have a couple P's in here, so let's not confuse them, but this P means profit. How do you create profit? It is revenue, which was 490x minus x squared divided by 10. There's our revenue equation minus our cost equation. This should seem familiar, right? Okay, so now if we take the derivative of this, we could go ahead and find our derivative. We'd find our maximum profit. But let's see, is there any simplification we could do? Well, sure. This would be 490x minus x squared divided by 10 minus 78,000 minus 120x. So therefore, profit is equal to, combining like terms, 490 minus 120 would be what, 370, I believe. Yes, I think so. Minus x squared divided by 10 minus 7,800 or 70,000. So now if we do our derivative, what does that do for us? The derivative of this, p prime or dp dx, either which way, would be 370 minus x divided by 5. So here we go. So let's go ahead and subtract the 370, multiply by -5. So 370 times 5. 1,850. 1,850. So therefore, x is 1,850. So what does that mean? We maximize our profit. And I didn't mention this explicitly because we've done it a few times now, but what do I do with this when I'm trying to find maxes or mins? Set it equal to 0, right? Okay, so, all right, so what does this mean? We just figured out we were going to maximize our profit when x equals 1,850, when we sell 1,850 sets. Notice, does this number match the number from maximizing revenue? Well, no, because your cost changes by the number of sets that you make. So therefore, there is not, just because you can bring in the most money doesn't mean you're going to make the most profit. You need to find a time when both of those things are true, when both of the revenue and the cost are at play, so that way you can see where your profits will be the best. Seems obvious probably for some of you who have done some business type application problems. But I just always like to make that point because sometimes students don't see the difference between profit and revenue. So cost is very important, right? You can't figure out how much you're going to make unless you know your cost. And since the cost is not constant, the cost is changing because it's 120 times x. It's there is an optimal at 1,850 units. But is this what the question was asking us to find? Let's see. How should the company set the size of the rebate? It doesn't, we don't want X. That's not our answer, right? So once again, we say, how should we set the size of the rebate? And we already have that equation from before. The rebate is equal to X minus 1,300 divided by 240. So that is the number of rebates. So now we're kind of repeating ourselves. So I'm going to go ahead and put that information down for you and see if we get the same answer. Okay, so substituting our 1,850 into the equation and solving it out, we get 55 divided by 24. And remembering that R represented the number of rebates, and those were $24 rebates. So when I multiply by 24, that divides with that, giving me the amount that my rebate should be would be $55. So I should be giving a $55 rebate to maximize my profits. What is that? I don't know. The problem didn't ask for it, so I'm not figuring it out. But if I wanted to figure out what my max profits were, I could again take my 1,850 and sub it in to my profit equation and get my profit. Okay, last problem I want to go through with you guys is just to remind you that not all problems have to be business. There are some very important geometry ideas in business. I guess I should say not profit and cost or revenue. There's other ideas in business, such as if you're in manufacturing and you want to have optimal, making boxes or cans and making the most efficient use of your materials. So there's all sorts of different applications. So here's a quick just geometry problem just to kind of remind you guys. So here it's saying if you have 120 feet of fence to construct a pen with 4 equal sized stalls. If the pen is rectangular and shaped like the one below, what are the dimensions of the pen with the largest area and what is the area? So whenever we don't know something in algebra, we use variables, right? So let's go ahead and say, all right, I know this wall would be length x, length x, length x, length x. These are all length x's, right? Now, or you could call them h's for heights, whatever you want to do it. And let's see, it tells us that the pen is rectangular in shape, but it doesn't tell us that these have to be squares. So what we're going to do is say let's come up with a relationship for the other sides and see what we can do. Now we do know that these need to be equal, so we can't say like y, z. We know that all of these, the length of one has to be the same as all of these. So let's see what we can come up with here. Now my personal preference is always saying, okay, it's called the objective equation. What's your goal? And our goal here is to create a pen of the largest area. So if I'm kind of stumped on a problem, I like to start there and say, what's my goal? All right, I want to find area. And I know this thing has to be a rectangle. So we find area by doing length times width. So what we'll do is we'll say, all right, I know the area of this would be x times y. Now, I don't know how to do the derivative yet if there's two variables. So what we will do instead is see if we can come up with another equation. Is there some other equation that we can somehow relate x's and y's? Well, yeah, because we know we have 120 feet of fencing. And so therefore I know if I add up all my x sides, how many sides are there? There's 1x, 2, 3, 4, 5 x's. Whatever amount of fence I use to make those walls, right? This wall, 1 wall, 2 wall, 3 wall, 4 wall, 5 walls, right? Then I have how many y's? Well, I'm going to have one amount of y's and another on the other side to fence the whole thing in. So 5 x's plus 2 y's. That's how much fence I'm going to use. That needs to be 120 feet. So now the good news here, I can now, with my two equations, I could solve for y and sub it in, or I could solve for x and sub it in. So let's pick a variable and solve. To me, it doesn't really matter all that much. Sometimes what you could do is kind of look ahead and say, what is the problem asking for x or is it asking for y? Because then maybe you'd want to sub in for the other one. So the variable you don't want goes away. But in this case, since they just want to know what are the dimensions that will maximize the area, we need x and y anyway. So just pick one. All right, let's solve for, I don't know, y. We'll solve for y. So that would be y would be equal to 120 minus 5x, not 50, try again, 5x divided by 2. Okay, so there's our equation for y, and if you wanted to, you could always rewrite it as 60 minus 5 halves x, just whatever you prefer. But the idea here is now what we're going to do is we're going to take this equation and sub it into the thing we're trying to min or max. We're going to say, okay, if I sub that in here, everywhere I have a y, I can replace that with 60 minus 5 halves x. And now you'll notice when I distribute this through, we now have a function for area with respect to one variable. I know how to do derivatives for one variable. Yay for me, right? So now when we do this derivative, all right, so we have dA dx is equal to 60. Bring the 2 out to the front, so that's minus 5x. Wow, that worked out pretty nice. So now if I set this equal to 0, because if I want to find the maximum area, I set that thing equal to 0. That's bad notation. Let's just do that. Add the 5x, divide by 5. So that's going to give me what? X equals 112, right? So therefore now I know x is 12. So fantastic. The x is solved for. X, there's one of our answers. So now to be able to figure out the other dimension, I need to know y. And the good news, I have an equation right here that has x's and y's. So what I can do is say, all right, I know x is 12, so therefore 120 equals 5 times 12 plus 2y. And that right there will tell me what my y should be. So I subtract the 60, so that's 60 equals 2y, so therefore y equals 30. And voila. So the question asks for what are the dimensions of this shape that result in the maximum area, and it is a 12 by 30, and I believe this was measured in feet. Yes. So 12 feet. So I guess we should add in to be good. We should say it's 12 feet by 30 feet. And there you go. That will maximize our area. Did it ask us for the maximum area? Oh, yep, there it is. Don't forget to always check. And what is that area? Okay, so what is that area? Well, now that's easy though, right? Because therefore we'd just say its area is 12 by 30. So area equals 12 times 30. So let's see, 3 times 12 is 36, times 10 is 360. 12 by feet and an area of 360 feet squared. Okay, so I highly, 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 highly implore you to not watch videos. Whoops, excuse me. Do not watch videos. Do not look for the easy way to do anything here. Okay, on every single one of these problems. Whoops, let's go back to where we were. There we go. On every single problem, do not look for a way to use your calculator to get around you doing the math, doing the algebra, doing the calculus. You need to know how to do this stuff by hand. You need to know how to set up these problems. Do not look for cheats. Because unfortunately, it seems like whatever happens, it's always happens on a test. That whatever scheme a student comes up with and a way to avoid doing the work never seems to work on the test. Okay, so I hope this gets you going, and good luck. And the keys here is revert back to formulas. Use as much information as you can. Use the information that's provided in the problem, and then always make sure you're answering the questions that are being asked, because there's nothing worse than doing all the work right and just not writing down the right answer.
Okay, best of luck.